Hi, everybody. In this video, we're going to talk about compositions or composite functions. In particular, we're going to talk about dilation. So the first two transformations we learned about are translations and dilation. So we're going to do a composition of a translation and a dilation. So first things first, let me go ahead and explain what a composite function is. A composite function is basically combining two functions, right? So I'm going to actually write the function rule for the one that we have here. So we have that it was dilated by a factor of 1/2. That's the first thing that happened. And then it was translated 2 units to the right and 3 units down. That is the second thing that happened. The way we show that that happens is by writing the translation rule first, because we work the composite functions inside out. So this is 2 units to the right. That means my A is a +2. And this is 3 units down. That means my B is a -3. So that means +2, -3. And then we're going to use parentheses here. So this is the operation. Remember, we talked about that before. This is the operation. And I'm going to perform this operation on the dilation. So the dilation was a dilation of 1/2. Okay. And we're going to do that to the original points, the pre-image. After we get our dilation, then we're going to take those points and do the transformation rule on it. That's why we have the dilation on the inside, because it happens first, and the translation on the outside because it happens second. So we work, again, a composite function inside out. Another way of writing this rule, would be T right here, like -3, right? And then you would do a little composite. This is something that you'll see in Math 3, a circle, D 1/2. That also tells us that we are doing a composite function. All right. So once again, we would do this first, and then we would do this second. So we worked it inside out. Now, let's explicitly talk about the domain and range of these composite functions. All right. So this is the pre-image. This is what we start off with. All right. And after we perform this transformation, we're going to end up with a new set of points. This is going to be our image. It's not going to be our final image. It's going to be what we call our intermediate image, because we're doing 2 transformations on these points. So this is going to be our intermediate image. So let's go ahead and find the new points. So remember, with the rule of 1/2 of xy, that means we're going to take 1/2 of x and 1/2 of y. So 1/2 of -2, 1/2 of 0, 1/2 of -4, 1/2 of 4, 1/2 of -2, and 1/2 of 5, and then 1/2 of -1, and 1/2 of 2. So our new points are going to be 1/2 of -2 is -1, 1/2 of 0 is 0. 1/2 of -4 is -2, 1/2 of 4 is 2. 1/2 of -2 is -1, 1/2 of 5 is 2.5. I'm going to leave it as a fraction as 5/2. And then 1/2 of -1 is -1/2, and 1/2 of 2 is 1. So that's our intermediate points. That's our images. Okay. So now let me tell you what was going to happen. We're going to take these points. This is our intermediate points. We're going to take those points. Let's put them down here. We're going to take those points, and they become the new domain for this second function. So they become the new domain for the second function. Let me just say that. So let's recap. We started off with the pre-image. We performed the function rule to it by doing a dilation of a half. And that gave us our intermediate image points. Okay. And then we take these intermediate image points and they become our new pre-image, our new domain. And we're going to perform the rule on that by translating it 2 units to the right and 3 units down. So we're going to say -1 plus 2. That means we're going to add 2 to all the x coordinates. Add 2 to all the x coordinates. And then we're going to subtract 3 from all the y coordinates. Subtract 3 from all the y coordinates. And so that gives us a new set of points. And this is going to be my final image point. This is going to be my final image. This is after we do all the transformations that the rule told us to do. So my final image points are going to be -1 plus 2 is a +1. All right, 0 minus 3 is -3. -2 plus 2 is 0. 2 minus 3 is -1. -1 plus 2 is 1. 5/2 minus 3 is a half, a -1/2. -1/2 plus 2 is 3 halves, +3 halves. And 1 minus 3 is -2. All right. And so that is our final image point. Now let's take a look at the graph of this. And what I'm going to do with the graph is I'm going to first, we have our pre-image already plotted. I'm going to first graph the intermediate image first so that you can see what the transformation is. All right, take a look at the picture. So our intermediate here is in blue. All right, I made that in blue. And so you can see that our figure went from a big figure to a small figure. We knew that because the scale factor was between 0 and 1. The scale factor is a half. And so our image got smaller. It was a reduction. And so that's just the first transformation. Now we want to take that transformation and we want to move it 2 units to the right and 3 units down. So let's do that in a different color. Let's do that in red. How about that? We'll do that in red. So we're just going to plot the final image points here. We're going to plot these final image points to show the full 2 transformations that were happened. All right, I decided to use green instead because the original image was red. So in the color green here, you see that this figure was moved to the right 2 units, okay? And it was moved down 3 units. All right, so there goes our final, this is our final image right here. This is our final image. And that's how you do a composite function. So let's say this again. You remember you work it inside out. So you work the composite functions inside out. Inside out. All right, thank you for your time.